start. Do you see my screen now? You see it well or not? Please write in the chat. How do you see? I have to increase the size of my fonts. Please write in the chat. Gbogbo, Yusuf, how do you see coding here? Good, so you see it. Okay, for you, both of you have to prepare some laboratory works. Yes? And one of them will be working with the files. It is working today, will work today with the files. So the name of this laboratory IO lab will be. And in this IO lab, I will create for you IO lab demo. And what we'll do here, at first about file, how we can describe file. At first, let's create file. We have file tasks. Yes, we have these tasks, these file tasks. Pass to this file could be in both formats. One of them is relative and one of them is absolute pass. Let's analyze it. This is absolute pass. And this is relative pass. And this is relative pass. So these are two pass. What is relative pass also? Also we have readme. Let's look at readme file. Okay. Copy relative pass. Let's try to also put here this file, relative pass to readme. Yes, also relative pass. And also absolute pass. Let's do relative pass to. So you see what we have. Copy, pass. So we have this pass. You also understand that this is Unix operating system. So in Windows, your pass will be like this one. You will put this, something like C, users, your user name folder, some work. So this is what we have. This is what we have. Let's try to read the. So you know that we have scanner, yes? Scanner. Scanner. Let me try. Okay, first of all, let me also explain some theory. Theory. TXT. So in Java we have two streams, because if we are talking about files, input and output, we are talking about streams of data streams. What the streams could be? It could be character streams, and it could be byte streams. We have two types of our streams, and what we can do. This is IO stream, character and byte. If you're talking about character stream, what we have? We have some characters like files I shown for you, and also we will have to work with them. Usually we have some classes to process them. For processing of character streams, we will have usually it's files like scanner, it's for input. For input, names of files are classes are scanner, and multiple different classes which have a reader in its suffix. If you are talking about something which is output, we are talking about different writers. If you are talking about byte streams, we are talking about input stream, output stream without reader or writer, something like this. And also we are talking about blocking operations, and we are talking about, it's not about blocking, we are talking about so okay, now because in Java we also have this is IO library, which is synchronous library, synchronous. And this is we will talk about this library because it's simplest way, and in our laboratory works enough to use this library. This is more efficient for small files and multiple connections and open resources. Okay, scanner. Scanner can take in the input something like structure. Okay, let me declare it here, file. And you see that You can find it out here. And we have relative pass or absolute pass. And now what we will do? We will do, okay, at first what I do in here. So I declare a file. This data structure holds only some container or wrapper around the data. It's not about data, it's only about location of this file. So this is only about location. So we don't know if this file exists or not. We also can check file exists or not exists. File exists. We can print on a screen. It exists or not. This file exists or not exists. Let's check. File exists. Yes, and what we have? What do we have? Let's run our file. And let's see it exists or not exists. Yes, file exists. Also, let's check another file, it exists or not. We have, let's copy and paste this path here. And we will see. Let's simply omit one letter in the name of our file. I'll omit this file and we can run this command. File2 exists or not? Let's check. And we see that this file is not exists. So you see the file does not exist. Good. Also, what we can get from this file? Let's check methods in this, what we have. We can create directories, we can list something, so we can list and obtain some files inside directory. For instance, let's check what files or directories do we have. We have in our command line prompt okay, we have, what do we have here? We have temporary files. Let's go to home, IC4, and do you see I have these files here? Yes, you see these files. We have these files. Let's get file listing here, and let's look on the files here. What I will do? For F, or in this way, file we have this pass, and now the directory, and we have list. Okay, let's get list because it's interesting. List, and now what do we have? We will have 4. Also, it allows us to check, but what we will do, we will file. Let's check what do we have in this case. You see that we have file listing. We obtain names of files inside our directory. You see they are present here. You see them here, and we also can see them here. You see it. That's file listing. It's clear for you or not? Yusuf and Gogbo. How to list files in the directory. Do you hear me or not? Gogbo, Yusuf. Okay, so this is file listing. Let's read contents of our readme file. What I will do here, I comment out this. Let's read our file. Let's read it. And also try, and here we put catch IO exception. We handle exception which can arise, and what we will do, system out println scanner while scanner has next line. So let's run our program. And we obtain the contents of our file. If you want, we can read this file. Yes, and we see on the screen the contents of another file. Wow, file does not exist. Unfortunately not. Unfortunately not. So let's also nice option here. We can handle also file not found exception. Yes, we can do this. And we can handle these exceptions. We can handle multiple exceptions. IO exception. Yes, and we can handle file was not found. Let's try to run this program. and you see this message. Yes, we don't have some exception, but we see that sorry, file not found. So this is some graceful message for the user. But we know how to read our file. We simply fix the name of our file. Omitted letter is here, present, it's present now. I run program again, and we see that our program runs successfully. We see everything from our file here, yes, on the screen. So you see everything from file on the screen. So it works. We know how to list files in a directory. We know how to read line by line file. And also, if file does not exist, we can print on a screen something. Yes, this is how our Java program handle exceptions. If something missed or something gone wrong, our Java program, for instance, if something gone wrong here, because this is potentially a dangerous line of code, it is enclosed by this parenthesis, and here also this is resource, sorry, this is potentially dangerous resource, but potentially wrong code, this place is here. And what can happen here? At first, you can have problem with reading of file. File can be not, file may not exist, and in this case, system can throw for you exception that file not found exception. And to do proper exception handling, we should add this piece of code. Also, if there are problems with another pieces of your code, we can handle it in this way. So this is how we do it here. This is how we do it here, how we can handle these problems. If you don't understand something, please feel free to write your questions in the chat. You hear me well or not? Write, please. And do you understand me what I'm talking? Maybe you have some questions. If it's clear for you, then we can move forward. If somebody knows how to work with Python, you also have in Python try and catch, try, except, and finally blocks. Maybe you have heard about these things. So this is how we can read file with a scanner. In the same way, we can read file with a reader. Let me show for you this. Okay, let me try to, I will type it again. We can do this in this way. File reader equals new file reader, and also I put here the name of my file, f2, and you see that Java highlighting for me that also we can have this exception. So find and found exception. Okay, let's do this. Try reader, enclose it with parentheses, and put here catch file not found exception f and f e, yes, and here we will handle it. But also we have highlighting the whole piece of code, because we also have Java IO exception, so we also should add additional block of our code, which is IO exception. So now we have the same pieces of code like you saw here. And also here we can do while file reader, and what we can do here, we will read something, but what we can read, unfortunately, file reader is not efficient. It's not efficient way, so better to use something which enclose file reader and allows you, because file reader can read only one character. This is character, one character. What we have to do, we have to use, it's not efficient, okay, let's do it, but let's declare some character. Yes. And also we can what we have, we read it character, yes, sorry, file character read, and the end character, what is the end of character is, will be no, sorry, why it is not end of file, we should read end of file character is what is end of file character? In this case we will have sorry, end of file we have in not in Java. We can iterate over all our file, and end of file we can do what we can do, sorry, we can read it while it will not read -1. Let's do it -1. It will be, sorry, I will not do it in this way, I simply will read it as int. Okay, sorry. Now it is okay. Yes, and now what we will do now, we will print salt, print ch, but let's print it as a character. So let's try to print on a screen this piece of code. Maybe it's a bit strange, but what we will see here, we printed all of our text. You see, this is from the first. This is the first our part of our program, and second one. You see it, yes? So symbol by symbol reading. It's not efficient. It's not efficient. Sure, you can do the next. You can do the next if you have okay, current character equals to ch, but before this we cast it to character. Here we put this is character. Yes, if current char equals to line break, what we will do, we will system out println, but in other case we'll simply print it on a screen. Let's try to run our program again, and in this case you saw we have the same result. Yes, here. So we obtain proper printing here. So also what we can do, we can do println, and in other case, okay, so this is some handling, but it's not good option because it's not efficient. What we have to do, we will use buffered reader. What we can do, we use buffered reader. How we will use it? We will use it in this way: buffered reader, new buffered reader, and here will be new file reader. So you see that inside buffered reader constructor we will have our file reader. So this way will be more efficient, and in this case we will omit all of these redundant pieces of code, not efficient, and by the means of file reader, buffered reader, sorry, we can read also the whole line, like in the previous case. So what we will do, while file reader read line, we can declare it in this way: read line. What we will do, we will declare string here, string new line. Yes, and here we put new line equals to file reader, not equal to null. We can handle it in this way. We can read it and also print on a screen result. So it's more efficient way. And nowadays I suggest you to use this way of handling lines of code. So now you see we have the same results like in previous case, because you see that this is using of scanner for reading, and this is using of but I see we omit something. I don't know why. You see this, yes, object-oriented programming, OOP. Let's analyze. We omit also something. We omit object-oriented programming, OOP, polymorphism, encapsulation. We have missed one by line. Why? Let's. Sorry. Right. Absolutely right. Oh, my mistake. We should use new line. Absolutely right. Because one line written here and one line read here. So let's run this, and what we see here, we have everything the same. Yes, you see everything looks like the same. In the same way we have this representation. So how we can do it? So it's okay. Yes, now you see these both options. So these are two ways of reading. And also we have collections, and third one option I'll show you. It will be simplest way. In this case, what we will do it in the next way. We have utility files, we have read all lines, we declare variable passes get, we put and we have name of files, yes, absolute pass, let's use this one, absolute pass, and we have declare path to our file, path to our file equals to read all lines, and here we will put pass to our file. Yes. Also we have to handle exception. Yes, it's crucial. You have to use them. You have to handle all of your exception because it's crucial because in other way Java will not allow you to compile your program, and in any case you have to handle some dangerous places in your code to prevent unpredictable things and to prevent crashing of your program if this file is not exists. What we will do, read all lines, and result of this operation will be a list of strings. Let me do it more evidently and use lines, yes, or strings from our file. Yes, read them. And now what we can do it now in this way. We can do it in such a way. We can do string, yes, as lines, and print it on a screen. Yes, so we have three different ways of printing this information on a screen. Let me also run my program again. Oh, sorry. Again. Here. So we run this code. Unfortunately, it's not unfortunately, it's another file. So we see another lines. Also, we can reduce amount of the code here. In what way? We can do it in this way. We can do it by for each and put here consumer, this piece of code here. I remove these things, this, and also IntelliJ IDEA suggests me to decrease. These both lines are doing the same things. They are printing on a screen. So we have few ways of print on the screen and read how to read our file. So we know how to read it. Also the question how to write the file. Okay, I will left here only one way, not this, and maybe not this, but this is rather efficient way. And how to write to file. How to write to file. We have file writer here. fv equals to new file writer. And we put here home Andrei IC4, yes, and new file. this file does not exist. Let me show you that this file does not exist here. This file does not exist here. If you see it, I believe you see it, yes, that this file is not here. It's not present. Now, you see, we don't have a new file here. No one. So let's create it and write to it something. New file, yes. And what we will do now, we also use try with resources. This resource is enclosed by these parentheses, and put here catch exception, IO exception. It's more general exception than other. We handle this exception here. We handle it in the simplest way, in a print stack trace. And what we will do, what information we'll write here. I suggest you to create array of strings, or better to use list of strings like array, yes. And students present in our class. It will be good, yes, in our class. So what students do we have? List of. Let's yes. Who also we have Raja, and we have Okubuna. And now, if I ask you, did you attend my class? You will tell me, oh, please look in your code. We were in the class. We attend your classes. We attended your classes, yes? File writer. And now, what we will do students for each file writer. Okay, student. Yes, we take a student and file writer. Write each student to our class. But let's okay it won't do it in the simplest way. Okay, for student string student in students in our class. So we do it in the simplest way. Yes, we do it in the simplest way. We run our program, and let's analyze this program. Let's do the next. Let's put this piece of code as a constant. Yes, this constant. And the same constant we will read here. Yes, we read it. So we read this constant. So let's check. Here we write and here we read. We run this code. And you see, oh, we see our students. But we see them without any spaces. It's not one name. Yes, it should be at least one by one. What we will do here? We will do here the next. We'll put here also file writer, write break of our line. So now if I run my code again, in my file I will see 3 students, 1 per line. But also you can ask me, but tell me please, we write in our file these names of students. Let's do the next. Imagine that our students will attend our classes. File write. Let's do the next. And now what we have, student, yes, attend my class, and also put here break of my line. Yes, here, and put here student, and also put here local date time now, something like this. And formatter, format, let's try to do it again. I prepared my string. Oh, in this line of code I have some exception. Why? Because here should be formatter. Let's look in documentation how should look like our formatter. Yes, I made some mistake. Let's look and check it. Okay, what happened here? Okay, let me check. Let's okay, we had I had exception, yes, because we will not substitute it properly data here. Illegal format conversion exception, where we have had it. Let's check, and let's check also documentation, because formatter, it's a class which allows us to format string into the most sufficient way, and we can also do the next. Let's do maybe in most simplest way, bit string format, and let's try to do it in one line, because it's too complicated to have it multiple. Oh, sorry, this was my mistake. Yes. And here tell me, but I missed that I simply write in the wrong order. You see, it works, and you see that student Gbogbo attend my class at this time. You see that milliseconds are written in a proper way. Yes, so different milliseconds. But we have the question, we have a log. We run our program again, but we want to know that the students also will be here, and we want to see that they are here again. Yes, but file will be only rewritten. So we have to put here in file writer additional option which called true. These options are the name of our file, it's a string, and also it's a true. True means that this is appending to the end of my file. I run my program and I see 6 students. Wow, I see more students. I run my program again, and you see how many students I have in my program. So I add them into my program here, and I append my file. So we know now how to write to our file, text file, and how to read from it. These are two simplest ways how to read and write files. Did you get what I explained for you here? How to read and how to write to your file. Is it clear for you? Please write in the chat. Gbogbo Raja. It is clear. Yes, good. So now we also will talk about interesting thing, because in Java we can also work not only with text files, but also we can work with byte arrays and files with the bytes. What I mean? I mean that if you are talking about image file with the image, we are talking about some byte array. Let's look into some file. For instance, we have program. Let's check what is a program. I don't know what is a program. This is some program in a C language. Do you see it? It's a program in a C language. Good. If you check this program file up, run, it's usual ELF 64-bit LSB shared object, which allows you to work this file could be executed in Linux operating system. Its dynamically linked interpreter is here, and build ID is here. So let's start to work with this file. And what we will do here? What we'll do here? Very simple. We'll do it in the simplest way. Let's declare pass to our file. Pass to our file will be the next. This one, yes. And I put, okay, let me absolute pass. Home Andrei. Or maybe, okay, let me also copy. I have some images. Let me copy some image file. Let me find out. Okay, I have one image. Let me show you this image. This is a rather big image. If you see it, this image is something like this. Big data science. What are they? Data is growing faster than ever before. Okay, let's do in the next way. We have passed to our file, and now what I will do now, we have output pass. Let's copy and paste this file. New file. But this file will be PNG. Okay, let's read this file. File input stream. Applet pass. Yes, here. And also we see highlighted with red, so the same option. So we have also exception here, and try catch. Yes, because this is dangerous resource. File not found exception, like in the previous case. Yes, the simplest, and we are doing it very simple. Print stack trace. But also we have highlighting everything that it should be handled as with the IO exception. So now let's try to play with this resource. File input stream. At first, what we can do, we can read multiple different things from this file, from this input stream. At first, we can read all bytes. Yes, the simplest way, read all bytes. We can read byte by byte. We can check if it's available or not. Let's do this read all bytes. We declare byte array, all bytes of our file. Yes, we read it. Okay, and now in my file, in my array, it's byte array, we have all of these elements. Well, let's check how many elements do we have in our file. So length Let's check. And now we see that we have 82,447. Okay, let's check this file. Let's check this file. What is this file? Let's do the next. For this purpose, I will system out println file, new file, and with the pass I put here pass to our file, absolutely pass, yes, this one, and semicolon here, and let's check length of my file. Let's compare these results. Wow, the results are the same. So it's bytes. Let's imagine, please, how many kilobytes do we have in this file? How do you think? How many kilobytes this file have? Let's check. Wow, 81 kilobyte. What is the difference between this number and this number? These numbers are different. Let's check them. Let's try to divide them in this value and in this value. What is the difference? How do you think? Here we have 82, here we have 80. But if we check it without h at the end, we will see the number we saw before, yes? So the size of our file was printed perfectly, and we see that we have proper size of our files. And first one number is closer, because here operating system tried to print in a human format by dividing by 1000. Okay, so we have length of our file. Let's copy this file. How we can copy this file? Very simple. We have to declare output stream, file output stream equals to new file output stream, and we have output. We put here output. What we will do here? We will do write, yes, but what we can write? We can write the same array, all bytes of our file, write them, yes, and let's check. So we execute this code, and let's check file, new file png now. Yes, you see that this is png image. And let's check this file. You see this? The same file. So we did it. We copied this file. So now we did it in the simplest way. Also, we print in a screen the size of our file. We don't need it. We copy this, read these bytes and copy here. But the question, what we will do if the size of our file is too large? What we will do here? Also, we will use buffered input stream, like in previous case, because we will use we will copy it only byte by byte. It's not efficient. So we will use something which in Java called pattern decorator. We should know that in Java input-output streams are written according to decorator pattern. It's one of the structural patterns of gang of 4. It's one of 23 patterns. 23 patterns. Buffered input stream, new file input stream. Yes, we have it. And buffered output stream. And now what we will do, while input stream read n bytes, for instance int buffer size equals to only one thing which is not good. It is about what we should and now we have to write these bytes into out file. Only one thing which is not good, because if we read these files we can have problem that we may reach out from the size of our file, and in this case let's check. The length of my file will be different than if you look here, you will see that -L, that the size now is not the same like in previous case. You see that size is a bit different, unfortunately. So in this case we miss few bytes. That's why we have to check properly what the size of input file and what the size of output file. But to prevent this, I suggest to you to use more efficient way and more simplest way, do the same operations. What operations you will use and what you will do, what I suggest you to do. I suggest you to, but you should know this option, because here you have to play with the same of your buffer. I suggest you to use more simplest thing, because in a class files we have read all bytes. Read all bytes, and you can read these bytes, and you can also copy. You can do in copy of your data somewhere, and source and output. Yes. You can copy your data where you prefer, from input stream. So here you can copy from local file to network. You can copy from network to local file. How do you prefer? You can create directories, you can create files, create links or symbolic link, temporary directories you can create, check if file exists or not, you can find file, you can get file attributes according to some criteria, you can get information from about your file system, about file system POSIX permissions, check if some file is a directory or not, because directory is ordinary file with additional properties. Check if file is executable, it's hidden or not, it's readable, it's regular file or not regular file. Check these two files are the same or not the same. And you can do another options to create new buffered reader, new buffered writer, new byte channel. It's for NIO, new input output. So you have multiple different options here, which are more convenient than using of things I shown for you. Let's try to copy. Yes, what we will do? We will do in very simple way. Pass get absolute pass what we will do, new file output stream and buffered output stream to be more efficient. Output. And now this program hang up. So the program finished successfully, and let's now check output file. What will be the size of our file? Here we're not talking about the creator. Copy. File appeared or not. Oh, sorry, I forgot again. Automatically. No such file or directory. Let's check again. Files copy. Let's check again documentation. Better to show for you this from my screen. Okay. So let me show for you how to copy everything. Yeah, strange why it won't copy. I don't know. Let me try to run this program again. Files copy. Yes, we have this file now. I don't know, let's check it's properly copied or not. Oh, it's properly copied. Yes, we have it. We copy it with the one line of a code. So this is code. So I didn't run this program properly before.